This video will cover the topic, factoring a difference of squares in one variable, advanced. Let's start by putting up an example problem. That way, we can reference this specific problem while we go through the steps of how to factor a difference of squares. Recall that multiplying conjugate binomials results in one squared term subtracted from another squared term, which is sometimes called a difference of squares. This fact allows us to quickly factor any difference of squares. If this doesn't seem familiar, review the topic, multiplying conjugate binomials, univariate. To factor a difference of squares, we first take the square root of both of our terms. We will use only the principal square root, which is the positive square root. Let's rewrite 81u squared as 81 times u squared, which is an equivalent expression. The square root of 81 is 9, and the square root of u squared is u. So now we can recombine our term, yielding 9u as the square root of 81u squared. Next, we know that the principal square root of 64 is 8, so let's write that here.
Okay, I'm a little lost. Why did I want those numbers?
Those numbers are going to be the terms used in the factored expression. One factor is the sum of those square roots, and one factor is the difference between those two square roots.
Yeah, but what about the number in front of the u?
Good question. The a term in the general example consists of the entire term in our specific example. So 9u is represented by a, in the same way that 8 is represented by b.
So now what do I do with those numbers?
So if we start with the difference of squares formula, based off the information we just learned, we know that it can be factored in the following form. This leads to an answer of 9u plus 8 times 9u minus 8.
Okay, now that I understand how to factor a difference of squares, can we do another example?
Sure. Let's start off with the example problem 36h squared minus 121. We first take the principal square root of the first term, then the principal square root of the second term. This results in a equals 6h and b equals 11. Now that we have our values, we can insert them into our difference of squares formula. This results in 6h plus 11 times 6h minus 11 as our final answer.
Is there an instance where this formula doesn't work?
As long as the binomials are in the form of the difference of squares formula, a squared minus b squared, then this method will work. If we had a problem like 25x squared plus 16, this method would not work because the terms are added rather than subtracted. However, if we had a problem like 25x squared minus 16, this method would work since the problem is given in difference of squares form. We would then follow the same steps as before. We take the principal square root of our terms. This results in a equals 5x and b equals 4. We then insert them into our difference of squares formula. This results in 5x plus 4 times 5x minus 4 as our answer.
So to factor a difference of squares, we take the square root of both of our squared terms. One factor is the sum of those square roots, and one factor is the difference between those two square roots.
That's right.